yes, we have one more thing tonight, which is the panel. And since this is a special edition about programming languages used for audio, we're going to be talking about more programming languages. And we had this idea to put together a panel with each panelist representing a different programming language. So we've never done anything like this before, so really curious what's going to happen. So yeah, we have 4 amazing panelists, experts tonight. One of them actually created the language that they're representing. At least one other panelist participates in evolving the language. So we're going to talk about all of that later. But yeah, let me introduce our panelists: Ruth John, Ania Wszeborowska, Neil Burdock, and Jules Storer. So welcome. Thank you so much for being here with us tonight. And yeah, as a first question, I guess, can you just tell us a little bit about yourself, kind of what you do, what language you're representing tonight?
Yeah.
Oh, yeah. I guess in real life, you would like pass the mic to a person.
Yeah.
So now we have to, so we can do maybe Ruth, Anna, Neil, and Jules. Maybe, does that work?
Hello. Can you hear me okay?
Yep,
yes.
We can hear you.
Okay, great. Sorry, I had to unmute and unvideo. Who knows what happens when you press buttons on an interface. Hi, I'm Ruth. I'm a self-employed developer, creative developer based in the UK. I'm here representing web audio, which essentially boils down to JavaScript.
And you said you have been doing this for nearly 2 decades now, right?
I know, yeah. I had to apply for a job the other day and it came up. My first initial job was almost 20 years ago, which is, time flies, right?
So yeah, you're truly a veteran in that particular language. So that's, thank you very much for being with us tonight.
Thank you, Tara.
Yeah, I guess Ania, you're next.
Okay, hi everyone. Greetings from Berlin. It's still hot in here.
Okay.
So I'm representing Python today, which I've been involved with for the last 10 years, let's say, or more. And because I frequently speak at Python conferences and run workshops for underrepresented groups in tech, I got the status of a managing member in Python Software Foundation. Just gives me the rights to vote. Right, even though I work at Ableton in C++ and C, every day I still use Python. It would be my language of choice for rapid prototyping and for automating whatever I need to automate.
Cool. Yeah, thanks. Neil, are you around?
I'm around. Can you see me?
Hi, yes, we can see you, yes.
How's it going? So as I mentioned before, I'm the VP of Engineering at Lofelt. So Lofelt is a Haptics startup in Berlin. So not exactly audio programming, but very similar. Maybe I'll get into it a bit later. My role is more organizational than technical. So I guess my representation of Rust here today is more from the perspective of how has it helped organization in our situation. So like a small team with pretty, I would say, hard real-time cross-platform requirements succeed. I mean, the other benefits that we have are like we're building a greenfield set of haptic design and integration tools. So we don't have any legacy coming along with us. And I think Ian did a great job of explaining sort of the technical details of Rust. And I think my relationship is much more sort of organizational. So don't throw hard questions at me, thanks.
But I think Ian is sitting in the same room, right? So if you have hard language questions, you can poke him. Yeah.
He's there.
All right. So he's not too far. So,
no.
So that's good to know. Yeah, and finally, Jules.
Yeah, okay, me. Well, 20 years. I'm a proper veteran. I've been doing this stuff since the 90s. I think, yeah, back in the 90s was when I was first doing audio coding. That's when I was kicking off the whole Traction project that then to write a DAW, which is still going. From that came JUCE, which went on my next 15 years of career until I ended up at Rowley with that. I still am, but Traction is still going, and we're still doing that. So Traction is now like we've now also merged with Prism Sound, so we're doing audio interfaces, DAW plugins, and then over at Rowley, I've been doing and we make keyboards and controllers and other plugins, and so I've covered all the bases here. And so Soul is the thing I'm here representing tonight, which is Soul is my kind of attempt to sum up everything I've seen that I like and don't like over the last 20 years in audio, and try and sort of boil it all down to how I think it should be done. And we've been working on it for about 3 years now, but still going strong. And yeah, we'll looking to further. That's my main focus.
Right. So, and Soul stands for?
Soul language. That's pretty.
And you did a keynote about that at ADC a couple years ago, and I guess you're going to get more into that later as well, I guess. Cool. Yeah, thank you. That brings me to my next question. Basically, how are you currently using this language? The one you're representing. What are you doing with it, like right now? What are you using it for in your day-to-day job? And I don't know, should we go maybe the other way around? Like, I'm just imagining us sitting on the stage and like passing the mic in one direction, then to the other direction. So I don't know if that's going to work, but.
Name someone. Go for it. So
what?
Just name someone and go for it. We don't have to keep.
Okay, then let's do the same order as before. Yeah, maybe Ruth, Ania, Neil, and Jules.
Okay. This is actually quite a difficult question for me to answer, because the last sort of 6 to 9 months have been not really working on projects for various reasons, which I'm sure all aware of. Previous to that, it was a lot of experience-based work. The web's pretty good. I mean, I'm using JavaScript primarily. I'm working on the web. And this, like classic examples, things like games, WebGL, a lot of sort of online experiences. So a lot of art projects like to work with a browser because it gives accessibility to a lot of people. So some good examples weren't necessarily audio specific, but you integrate audio into those experiences. There's been, like last year, fundamentally a theme was interactive maps. There were games using interactive maps and interactive maps showing experiences that other people were having, and integrating audio like into the whole ecosystem is probably the easiest thing to say that I've personally been doing.
Cool. I guess
I feel like I've frozen the video.
Oh, sorry.
I feel like we've lost Timo. Have we lost Timo?
Yeah, I think we did.
Right, we're
He's
gonna
frozen.
Have to host ourselves, everybody.
I'm gonna step in. Go ahead, Anya.
Yeah. When I'm finished, I'm gonna say I'm passing on. Okay, so as I already mentioned, I use Python whenever I can for private projects, for prototyping things. Like recently I was trying to, I was experimenting with generative audio, and I was trying to get some concepts common use in generating graphic textures, and like adapt this concept to generating audio, for instance. And well, I was trying to do it in C++, but I was just wanted to check if this idea even makes sense, right? So I was thinking, okay, how about I just like quickly hack something together and see if the results are any interesting. So I was thinking, okay, what's the simplest way of coming up with like a simple GUI interface for my algorithm so that I can turn a knob simply. And like, it took me a day using only like the most lightweight frameworks to just come up with a GUI for something that I didn't even know I wanted to pursue. And I was like, you know what? I'm just gonna like sketch in Python. I used the built-in GUI library and hacked it in 15 minutes. And actually in the end, I decided I was not happy with what I was doing at all and just dropped it. So like, this is why I always like code things in Python first and then see if I actually want to productionize it later. Also, there are like great tools for like plotting curves and doing measurements. So basically I use Python as you would use MATLAB, for instance. So this is for, the audio things. We do use Python and Ableton too, to some extent. Also like Ableton Live is integrated, like communicates with Push and other hardware through Python scripts also. So I do that too at work, or just write my helper scripts too. But also like the reason why I started pursuing audio processing in Python was because people told me that it's not possible, and I guess I just did it and it worked. Like I don't suggest it, recommend it as like a tool for productionizing your audio projects, but like, well, it totally works for simple applications in real time also. And also for offline processing, you don't have a problem at all. So yeah, sorry, I've already taken up too much time. I'm gonna pass on to Neil. Was that the right order?
I think it's the right order, and I think we have Timo back.
Yeah, so I actually had a blackout right now. So like everything just bam. But now I'm tethering my phone now, so I should be back, I think. So sorry for that. We had a blackout here in Greece.
Great.
Remote working. What was the question? Okay, so how are we currently using this language? I mean, I guess I need to talk a little bit about what we do. And so why is someone talking about haptics on an audio programming panel? So we provide a haptic design tool and a cross-platform playback engine and plugins to basically try and design and recreate and playback more natural, realistic, richer haptics in sort of games, movies, music than you have traditionally become used to, which are like basically on-off buzzers or rumble in a PlayStation controller. And what's interesting about haptics and audio they are essentially, so haptics is to touch as audio is to hearing, and they are essentially two sides of the same coin. So we perceive audio as a interpretation of vibrations, and we interpret touch as interpretation of vibrations on the skin. Although on the skin, what we feel are lower frequency vibrations and maybe shorter bandwidth, but essentially it's the same thing. You're talking about waves over time that have a frequency and an amplitude. So a lot of the abstractions or requirements within hardware or software to develop haptic tools are very, very similar to what you would encounter in audio. So things that are similar are like we have real-time requirements, except that we can introduce bigger latency. So our skin is more, let's say, forgiving than the ear if you've got higher latency. Maybe some other differences are you can trick the skin much easier than you can trick the ear. So if you do a mixed modal haptic experience where somebody is looking at something that is telling them what they should feel, they will feel it. Their brain will make up a thing in their brain that tells them this is exactly the feeling of tapping on wood. So we, I guess, have it easier than the audio world. And so all the way back to how do we use Rust? So we wanted to build a set of tools that allow us to design and play back haptics. And we were doing it from scratch. And so we decided to start our core implementation of our library. So our data model and our DSP processing in Rust over C++. I mean, these were basically the two options that we had. And so on a daily basis, I don't myself work with Rust. I work with a team who works with Rust every day. And they basically build our data model. They analyze audio with Rust. They analyze audio in real time with Rust. What we don't do are things like build UIs. We don't call native APIs like in iOS. We just throw everything out to the iOS land and call things in Swift and Objective-C. So we have a very small, lightweight core library that runs on multiple platforms that is written in Rust. And I am around that on a daily basis.
All right. Thanks, Neil.
Me. Is this sounding any better, by the way? Apparently my
a lot better, yeah.
Yeah, it was bad because I had an ice pack on my computer to stop it overheating, so I've moved it now and should be good. Yeah, so what do I use Sol for on the mainly? To be honest, most of the Sol code I run are test suite because I'm working on the compiler. The kind of, I mean, do you want me to do a quick 1-minute summary? I think a lot of people will know about it, but
yeah, if you can do it, if you can do a 1 minute, I think that would be useful. Yeah, 1
minute's tough, but so Sol, yeah, Sol. The idea with Sol is it's a DSL language. I don't know. Actually, it was interesting watching Francesco's talk before. Francesco, you didn't mention Sol, but have you seen it?
Yeah, I did see it.
Because I was sort of looking at your Hello World, and it's like, yeah, that's exactly what we were going for. Like even the order's the same. And Sol is trying to kind of hit several, fix several problems. One of which is the same thing that you, Francesco, were probably thinking, and I was thinking as well. It's like, I want my code to look like that because that's what a DSP block should look like. You declare it's in inputs and outputs. You say what. You initialize it, and then you do sample, you loop and you do samples. That's how we should be writing DSP code. And to do that in C++ is awkward because you're threading, etc. So that was one thing I was trying to solve. Another thing we were trying to solve was being able to actually run code securely on different processors. So being able to send it to a DSP or to some other, or to something in a kernel. So being able to write code that is actually trustably secure. And so in a way, trying to hit the same problem that we're trying to address with Rust, whereby someone cannot write some dangerous crashing code in Sol. So trying to create a language where you can't do that, but where it's still fast, which is kind of, I think Sol and Rust are pretty much the only two flexible languages where it can be fast and you can't crash it. For us, the purpose of that was to be able to deploy the code to other non-trusted platforms. And the third thing was to make it easier to write. So again, making it hard to crash helps, but also making it, taking away all of the bad things that we don't want people to do in C++. So having sat and watched countless beginners come to JUCE writing C++ for the first time, they know what they want to do. They want to write some DSP code, and they're just making a complete hash of this C++ because it's such a difficult language, it's such a learning curve. And what they really need to do is go up that curve, learn how to do C++ properly, and then not use all of that stuff because you're not allowed to do all that stuff. You're not allowed to allocate or use threads. And so forget all the things you're not allowed to do and then learn even more rules about what not to do. We wanted to make a language where you simply you can't do them. They're not there. You can't, this is what you can do. It reads very familiarly to someone who's done any of the familiar languages like JavaScript or C++. And to sort of solve all of those, Sol is kind of our attempt at doing that and making it it's a very commercial project in the sense that it's not an academic project, it's not a toy project. We're trying to pitch something that's practically going to work and is going to solve all the use cases that we see in the industry. What am I doing on it day to day right now? Well, this week I've actually started looking at UI frameworks that we might want to use with it. I think probably what we're going to see happening with it is we'll have people writing their DSP code in Sol, but then using probably a JavaScript GUI around it. We're not going to be we're not going to try and force people into one UI framework or another, but I think React and JavaScript is probably where we're going to want to go. So I've been tinkering with that this week, and also working on our platform layer. So what the protocol is going to look like for controlling a remote Sol device over either across a network or across just from one process to another, or from one chip on a motherboard to another chip, kind of what that protocol looks like. So those are my kind of day-to-day concerns at the moment.
So it sounds like we have some exciting stuff to look forward to, and we're going to get to that
so much
later as well. Yeah. So, but before we get to the kind of exciting stuff, I think I have a more basic question, which I think you, Jules, already kind of answered, because you basically are developing this language and you got into it to solve these problems. But I'm really eager to hear from our other three panelists. Like, how did you get into using the language that we're talking about today? Like, why JavaScript and web audio? Why Rust? Why Python? Like, how did you like get into it? I'm just kind of curious. Like, how did it happen? If you don't mind sharing. Out of all the stuff that is there in tech and in audio,
Are we still going through the same order?
Yeah, I think.
Out. We're just grabbing the mic.
Yeah. Okay, let's do that. And I think, Jules, you kind of already talked about it, so we're gonna skip you this time around. If that's okay.
Okay. How did I get into web audio? It's kind of interesting because it wasn't really audio based. Obviously, one of the reasons I use JavaScript is because I know JavaScript. So, oh, hello. Am I still there?
You're breaking up, but we can still hear you.
Yeah, no, my computer's having a freak out now. Timur, it's like, it's here. It's going across Europe.
Okay, maybe if you speaks a bit slowly, then maybe it will happen, because it will be better, because you're breaking up a little bit, but we can still hear you. So
okay, thank you. Yeah, keep telling me if I.
It's fine. It's fine. Yeah, you're good.
It sort of goes back to what Anna was saying about quickly being able to visualize your ideas, which I mean, Python's a really good example of this, as is JavaScript, and my flavor was JavaScript, because you can so quickly build something without even really having to worry about build processes or compiling or tools. You have a browser and the code is just there in front of you. So I started playing around with web audio about 10 years ago when it first came out, to analyze frequencies for visuals, because I do a lot of visual art. That's basically where I sit. And it was through that I just became familiar with the API. It's more of a signal processing thing for me. So I may not be creating musical tracks with it, but I sort of fell into it through a visual route rather than a music route. And it's only now that I'm using it am I back into a musical route with it.
That's really interesting. Yeah, thanks for sharing that.
That's okay.
Anna.
Hi. So I think I can only refer to what Ruth has already said. This is like when you feel comfortable in a language, you know it well, and you just want to quickly sketch something. This is probably, what you go for. The other thing, so I felt like familiar with Python. I felt pretty quick in it, and that felt like a natural choice. But also, before I worked on audio projects, I had different reasons for using it. And then I was actually happy to see how well the Jupyter project progressed, because then it allowed me to also quickly interact with my code and plot things and so on and so on. So like, for people who don't know what it is, this is what I mentioned before. You can think of it as like MATLAB-like environment. And Python basically, the whole SciPy project supports a lot of, basically has like, maybe I can call them clones of what MATLAB offers also. Has all the libraries for signal processing. So a lot of things are just there, ready to be used. That works well. And the performance of Python is as good as MATLAB's, right? So like my colleagues sometimes use Octave, this open source clone of MATLAB, and this is like twice as slow. We also benchmarked it, whereas Python is only like slightly slower than MATLAB. So for prototyping and measuring things, it was actually quite convenient. But yeah, but pretty much like the reason why I used Python over other dynamically typed languages, or like I could have used JavaScript, but I felt more confident in Python. So. And then there's like a lot of room for optimization when you actually want to do something about your performance issues also. So that's also appealing to me. Yeah.
Oh, because it's like C under the hood somehow, somewhere? Oh, yeah.
Yeah, so when you, sometimes when you identify a bottleneck, you can just like rewrite parts of the code into C and write bindings, and that sometimes is sufficient. You maybe don't have to rewrite everything.
Yeah, I guess with JavaScript, you don't really have that, do you?
Yeah, I mean, I can see other benefits of using JavaScript, which is just like basically how easy it is to ship your product and like share it with other people. For instance, this is wonderful, right? So this is great, which also is something that you may do with Jupyter Notebook, right? You share, there's like a built-in, sorry, there's a web client and you can share your projects with people, but like, yeah. So basically there are other scenarios when one technology would be preferred over the other, right?
Yeah, I just want to butt in and say I've been on a very personal journey with performance in JavaScript, and I'm sure Python probably the choice. It's not been fun.
All right. So Neil, I'm really eager to hear, how did you have this idea to start doing stuff with Rust? Like, how do you just, as someone who's, obviously had a, career in this industry for some time before, at a company like Ableton, which as far as I know, does everything in like C and C++, and there's obviously some Python going on there apparently as well. How do you say, okay, now let's build the whole thing in Rust? Like, how do you get into that?
You definitely don't say that, because engineers are like, what the hell are you talking about? Well, I don't know. I guess the question of like, how do you get into using the language? I've only hands-on been using Rust for 18 months or something, but I've been following the language and the progression of the language since before 1.0. I can't think exactly how it appeared on my radar, but I mean, at the time I was working at Ableton, I think I was probably about a year and a half to the job there. And a lot of what I was doing, so I was a development manager for Live, and Live is a really massive and really complex C++ code base. Essentially, I was seeing things that people were having trouble with, and those were all the way from like bugs that are just very hard to diagnose and to fix. And I was working with a hiring team and hiring C++ engineers that have a certain amount of experience and aren't sort of 55-year-old white guys was a big challenge. And C++, it's a beautiful and very powerful and extremely well-used language, but it's not very inviting, and it's quite easy if you're a junior to make mistakes with it. And I was seeing this sort of all over the shop, and then Rust sort of raised its head in the world as a potential C++ challenger, which I don't think we've had for quite some time. And I had no ideas or thoughts or plans to try and introduce Rust at a place like Ableton. That doesn't make any sense. I mean, these code bases are mature and they are hardened and they are valuable, and they should be treated as such. But it was just something interesting for me to follow. And the more I followed the project, the more impressed I became sort of with its core ideas, with its governance. Actually, its project governance is very interesting. Sort of a more distributed open source model in comparison to the C++ standards committee. Of course, they have different requirements, and so different bureaucracy. And as I followed the project more and more, I became more and more impressed with sort of the people involved in the project, like Aaron Turin, ex-Mozilla, now I think Fastly he just joined, Steve Klebnik. I hope I'm not butchering these people's names. I've only ever seen them on Twitter. Steve Klabnik, Carol Nichols. They're responsible for the documentation culture, a lot of the documentation style, the book, the Rust book. I mean, these were just impressive people. They're, I don't know what you would say, but their care for what they did, I found very, very impressive. And so what started out as maybe this is something that can solve a problem that I see in a particular organization became more of a fascination in terms of like what a technical project could be. I just became quite fascinated with the project. And then when I joined Lofelt, we were coming out of a maybe 12-month R&D mode. We were doing a lot of research and development, doing prototypes into very many different areas it's not worth going into. But we had to then choose a language to write our core model in and our core DSP. And I felt that it just sort of all added up. I was like, this makes sense. We have to evaluate it. And evaluating it was not exactly like there were many languages to choose from with the requirements that we had. It really was narrowed down to C, C++, or Rust. That was it. And we did a fairly significant diligence job on well, we did, the engineers did a fantastic job on making this decision over a significant period of time. And so now I guess I'm more involved or into using the language because I'm around it every day. Whereas before it was just a personal, I don't know, hobby interest on the side for me to follow.
Right. Well, it sounds like it worked out for you quite well then.
I mean, so far, so good. It's not long.
Yeah.
I think we started using it in Feb or something.
Right.
So it has not been long, but so far, so good.
All right, then, yeah, good luck. I hope it works out. So yeah, we have 3 more questions to move through. I'm not sure if you're going to get to all of them, but let's see. So the next question, maybe we can start with Jules this time and kind of wrap around back to the original order. And I would really like to know what excites you the most about basically using the language for audio that you're representing. And are there specifically any recent developments that you would like to tell us about or that you're particularly excited about?
Well, I mean, to be honest, when you're writing your own language, when you type anything at all and it compiles and runs, it's kind of, it feels like a little miracle. When it's like when you're using, I've always had this with any software I write, like you watch your own software running and you're thinking, how is that actually managing to do that without, when you know what's going on in there and how much complexity is inside. But it does feel nice to use. When I actually get to write it, yeah, it's and you can actually express something and it's neat and sits on the page nicely. It's just I get a buzz out of the aesthetics of code like that. New exciting stuff. We've kind of taken the whole lockdown period as quite a good opportunity to just knuckle down and quietly get on with the back end diligence work. So part of what Sol needs to offer is like a secure layer that means you can run on devices with untrusted code. So we've been doing quite a lot of not front-end language work, but going in the back end and making sure our internal layers are all nice and tight and secure and well tested and refactoring. I wrote, one of the other funny things about doing something like a compiler is some features which sound very easy are very difficult and vice versa. So something like adding a little operator would sometimes take us like 2 months and have to rewrite half the code base to do it. But then last week it took me 2 or 3 days to add plugin delay compensation, so it can compensate for an entire graph. And it was like, oh, that just fell out. So nice little things like that.
Because usually that's really hard. And
I mean, that is ridiculously hard. Like,
because I've tried to do this a few times before, and it's really hard.
Bonkers, but that was really easy. Whereas, like, there are some things like we'll put it the tiniest little addition to the language. Oh God, I have to rewrite the whole type system now because it doesn't handle something and refactor the whole thing. This is one of the nice things that just pops out in the wash. And yeah, and the thing the sort of visible thing I'm really looking forward to focusing on next will be some GUI options and actually getting some GUI stuff. I'm going to play around with Nick Thompson's blueprint is my project for the week to see how feasible that is. And the other thing is we're going to we're about to kick off a little project to start building lots more DSP building blocks for like our standard library. So really get the basics in there all the time.
Right. So I'm looking forward to actually seeing that in action sometime.
Yeah.
So, cool. I'm just kind of moving on because it's getting later and later. So sorry, I didn't want to like cut you off or anything like that. It's just, you know. Ruth.
What excites me about web audio?
And whether there's any new developments that you are particularly excited about and want to share with us.
I just realized how hard it is to follow rules. It's like, yeah, I'm writing my own language. So I'm like, I didn't write web audio.
But you've been using it for, you know, much longer than, for example, I have even written any code, right? So, so you've been following all that. So it's like it's a different perspective, I guess, but I'm really interested in that perspective.
And it's kind of an interesting API. I think it's good for onboarding, and I sort of covered this. I think it's accessible. I teach on a boot camp here, a web development boot camp, and we have adult students, and we actually have quite a lot of musicians come through because they want to learn how to code. And it's really nice to have something like the web audio API because they have probably experienced some sort of code in some other software that they've used, and they can start to marry the web code that they're learning with their musical knowledge, which they've already accumulated throughout their career. So I really like the web audio for that. It's relatively straight to understand if you have a musical background. And once you've got the coding information on top, it's an easy in, I find. New stuff, we are working, so they have a working group for web audio, and what they do is they manage implementation in browsers, so web clients, as well as any functionality or specifications that need to be written or added. So they're moving through the end of version 1 now and into version 2, and what that means is there's an opportunity to add anything that people found was missing, anything that they want. There's a GitHub repo, it's all open source. I can send you a link after if you want to send it around. Anybody can get involved, and if you're using web audio and there's something that you feel is lacking or something that you don't like or you want, you can just raise an issue and you can just add it, and it's really cool. Some things that are exciting me about version 2, this is just a couple. There's a huge long list of issues which we're working through. Better buffer management, worklet integration with WebAssembly, which is going to be quite an interesting one. Noise generation, which is simple, but I think it's going to be really effective on the web. We don't really have anything like that in web code at the moment.
That's really cool.
Configuration, yeah, that is quite cool because I feel like that moves into any kind of generative, any kind of art space, is to have some proper noise in JavaScript, which we don't have. Random numbers, and that's it. And yeah, those are my list. That was my picks from the many issues that I went through earlier. So yeah, it's a really good time. And like I said, yeah, well, there's loads more, and I will send a link because there's a community group as well as the official working group, and anybody can just come in and just give their input, really, which is highly valued.
All right.
Thank you, Tim. Just realised it's really dark in here. I'm going to put a light on.
Yeah, I think that would be better, actually. So yeah, Anna, what's going on in the Python world? What are you excited about, and are there any like recent developments that we should all be excited about?
I'd say there's not like awful lot going on in Python regarding supporting audio processing, right? It's true and not true. So let me like elaborate on this. So first of all, I think, well, there are like a few projects that offer, that like build libraries useful for signal processing. that I follow and I'm excited about, and I'm always happy to see progress being done there. They're like, the names that come to mind immediately are PyO and Librosa. They're becoming quite comprehensive, so this is nice to follow. I wish there was more happening in the PyPy project, which is like an alternative Python interpreter written in like restricted Python. I like ported PyAudio, which is like a set of Python wrappers on port audio to be able to use it with PyPy some time ago. But like each time I wanted to like benchmark something on this compiler and well interpreter, and I thought it was promising. I just needed to just like add additions on my own, and it would be great. Like if I had infinite time, then probably I would just invest more time into doing that. But there doesn't seem to be like any active workgroups working on it currently. I think the area of computer music that's probably getting closest to the Python world, the Python community, is machine learning, right? And generative audio, because like there are a lot of Python tools that are commonly used in these communities, like, you know, Python wrappers to TensorFlow and so on. And I know that a lot of people use Python for generating musical patterns using machine learning. It's not necessarily my field of research, because like I tend to prefer deterministic algorithm over dealing with heuristics. It's just out of personal preference. But I think this is maybe the field that's emerging at the moment, right? Like Python is gaining popularity in these areas like data science and so on. I was on the programming committee for PyCon US 2 years ago, and pretty much half of the submissions was focused on data science and machine learning, AI in general. So I think this is the most active part in the Python community at the moment.
Right, thanks. So what about the Rust world?
I mean, I don't really know what I would add on top of Ian's talk. I mean, he talked a lot about just the essential benefits of the memory model and the ownership model that allow you to, well, that allow us really to move very quickly and just not experience crashes. One thing about the compiler that I really like about Rust that helps with audio programming or any sort of multi-threaded or real-time system is how amazingly written the errors are. Like, they are just really, really instructive, and they are teaching you all the time about how to program just a little bit better. I mean, they're obviously highly opinionated and they're based on the rules of the language, but they really do help you learn and not make you annoyed. Also, I think Ian mentioned sort of Nano and this and what they're doing in creative coding frameworks. This is a very exciting team. Actually, they're here in Berlin, and they're a part of the Rust Audio working group that I encourage anyone to go have a look at what, I think it's rust.audio, go have a look at what is going on there. There are a lot of interesting projects coming out. But I think what's exciting to me is more maybe along the lines of what Ruth was talking about. So we're using Rust to, so we compile some of our Rust to WebAssembly, and we run it on a backend server, and we run it in a Node, an Electron application on desktop. And we're doing this for DSP and for a data model. And the, let's say, the compilation story of Rust to WASM is just really quite incredible. And with the sort of the new standard for WASI, so the WebAssembly system interface, I think we have something very exciting in our hands where you can basically have headless WASM running anywhere, and you could write that in Rust, and you could run it in Rust, or you could ship it to a browser, or ship it to a WASI container in a network somewhere. This I find super exciting for the possibility of basically distributing audio code. It's very early days, who knows? But I find that the cross-platformness of this solution to be something that's been I don't know, I think it's burning in the audio industry. So we went from like desktop cross-platform, Mac and Windows, to embedded browsers, back-end systems, our cross-platform or mobile devices. The cross-platform situation is much more complicated now. And seeing a solution that might actually work and is secure coming out of the web world is exciting. And I like that Rust is looking at that as a target, or treating that target as a first-class citizen.
Cool. Well, amazing. Thank you. So I think we don't really have time. We had like 2 more questions that we wanted to ask, but we're kind of running out of time. So I think I'll wrap it up here. I just wanted to say one more thing. It felt to me at the beginning that I should kind of be the devil's advocate on this panel in a way, because I also kind of represent a programming language. Like, if people know like what I do, I'm all about C++. I'm like a voting member of the C++ standard committee. Working on the C++ language is like a significant part of what I do. And, you know, I've done audio plugins for several years, and then, you know, I've been on JUCE team for several years. So it's been all about C++. And a lot of people like do this stuff because it works really well. But right now I feel like this world is almost like, I feel a little bit like a dinosaur, because, you know, I've been listening to you like talking about all these amazing new things that I don't even know, but they all sound like, wow, maybe I should be using this, maybe I should be using that, you know. And it feels like the audio industry is kind of moving on in a way, and I find that really, really interesting. Although there's like, I feel even more that I know just a little bit, and there's like all of this gigantic pool of things that I have no idea about. But yeah, it's just so much exciting stuff out there. So yeah, I'd love to like discuss these like new trends, I guess, more with you, but you don't really have time for that. So because you also wanted to open the floor to some questions from the audience. So I think I'll just wrap it up from me by saying thank you so much for sharing, you know, all your excitement and all these insights. And I definitely learned a lot from all of you today. And I have a long list of things I need to look into now. So thank you very much for that as well. Yeah, so thanks a lot. And I'll let Josh take over and take a few questions from the audience.
Yeah, great. We have a couple questions here. So Scott has a question for Ania. Do you have any recommendations for VST hosting in Python for programmatically calling audio processing plugins from within Python code?
I unfortunately don't. I've wanted to write something like that some time ago. I heard of one project though. And yeah, I've heard only about one. I can try to look it up later, and
yeah,
I'll look up the person who asked, and maybe we can connect. But unfortunately, I don't have any immediate recommendations, which is a bummer.
Yeah, I've heard of a couple projects like that as well. And yeah, unfortunately, not really. I think one of the, you can correct me if I'm wrong, Ania, on this, one of the limitations of Python is that there aren't really any good UI libraries for it, or at least I've had trouble finding any good UIs for any sort of controls or anything like that.
Well, there are quite a few projects that you could use. Like I usually end up using the built-in library because I have very limited needs, I'd say, and I think I've also learned my way around it. But you know, you get wrappers for Qt or like more serious, I'd say, GUI libraries. So it is possible to integrate it with a good, fully functional GUI library. I don't think, yeah. Well, but integrating with Qt has its issues. But like, yeah, I think that's not the biggest problem. There are more challenges, I think. Yeah.
Thank you. So there's a question from Peter. I don't know if you can answer this, but are there any plans for embedded Python 3 in Ableton, and is live debugging from attached IntelliJ debugger possible? Not sure if you know that or can answer that if you do know.
Well, regarding any planning at Ableton, we would all have to be under an NDA to talk about this. But like regarding debugging, there is a hacky way to do it, but it's not officially supported, let's say.
Great.
So yeah, like yeah, there is an API, right, that we use to connect with remote scripts with like external hardware, but it's not like officially supported. We don't provide people with tools to develop on top of that.
Okay, great. And there's a question from Spencer for Ruth. How would you compare modern web audio to the way things were done before? Are there any tools or libraries that you use frequently? Oh, I'm sorry, I can't hear you, Ruth. I think your mic might be muted.
I thought it would be clever to mute because I was so hot.
Yeah.
When you say the way things were done before, is that background? Was it background audio tag? Yeah, obviously things have improved a lot since then. Not that there's anything wrong with a bit of background audio when you land on a website. That was a joke. What was the second part of the question? Sorry. Is there any libraries?
Are there any tools or libraries?
There's a ton.
Yeah.
Yeah, because JavaScript is basically libraries if we use it in production, isn't it? Tone.js is obviously one of the most popular. That's incredibly good for any kind of synthesis, any kind of transport timing systems. There's Howler, which is a popular one, which gives you just a layer on top of web audio. One thing about web APIs specifically is they're designed to be built on top of and not necessarily to be used as they come out the box. So you should build libraries on top of them. So Howler just gives a nice layer on top of web audio just to make some commands easier. Somebody I know sent me one just last week that they had built, which is a good contender by the looks for Howler. And I'm looking at my tabs because I swear I had it open because I can't remember the name. I think it's Sonorous. That is another link that I can provide afterwards. A company based out in New York and Tel Aviv, I believe, they do sort of video editing software in a browser. So they've in their labs department, they've created an audio library, which does look really promising. Like it just makes it easier. Obviously, there's the learning curve to learning any kind of libraries that sit on top of APIs. But yeah, there's a bunch. I can provide links.
Okay, great. Yeah, and what we'll do, if you could send me the links afterwards, and I'll put them in the description below the video afterwards. By the way, this video will be available afterwards for everybody to view, and I'll separate these as well. So there's another question for Ruth from Joshua. Is the web audio API suitable for making progressive web apps that can rival VSTs in functionality? Has there been any movement in terms of cross-browser compatibility for web MIDI? Yeah,
so one of the problems that we have, which I actually do think that, I mean, Neil was talking about it, I think everybody faces it at some point, and that's having something work consistently across the board, regardless of what you're building and for whom. You've either got backward compatibility problems with native, or you have browser inconsistency problems with the web, which is one of the fundamental problems of web development, which everybody faces. Progressive web apps are, if people are unaware, it's the idea that you can take your website code and create an installable application on your native device. One of the big trendsetters for this is Google. This works perfectly well on an Android device. One of the blockers that we always face is Apple. I think I heard something recently that Safari as a browser were not looking to implement MIDI, which is, and I just heard that's a rumor and I have nothing that confirms it. And one of the problems that we have with Safari by and large is they implemented an old version, well, one of the initial versions of web audio a number of years ago and haven't updated it to fall in line with spec. So there's a ton of stuff which just gets really icky and doesn't really work. And the other issue, of course, is that every single browser you use on an iPhone is Safari. Like Chrome is literally just a wrapper over the top. So under the hood, it's very, very difficult. MIDI is an interesting one. So not only do we have web audio, we have a web MIDI API, which allows you to send and receive MIDI messages. It's one of my favorites. It just hardware enables the browser so easily and so quickly. Works perfectly well in Edge, Chrome, Opera. Firefox are very, very close. They're like, and pray that the recent news isn't going to change that. But if Safari aren't doing it, that's a big blocker. I think the web industry can be quite blinkered to other industries that need things. That's a personal take. Like, I think if they were aware that MIDI would really change the way that we use audio on the web, they'd be more inclined to implement it. But it's still there. It's not going anywhere. You can still use it for Chrome. So, you know, when I'm doing personal projects, I really enjoy it.
Great. Neil, we have a question. Have you ever tried the PS5 DualSense, and where do you think the future of haptics is for game experiences?
So no, I haven't tried the DualSense, and I really do want to try a DualSense. It sounds fantastic. I'm really glad that I don't know, Sony and PlayStation have invested and made a sort of a first-class feature out of haptics. I guess it's good for us. Haven't tried it. Apparently, it's great. Then the question was, where do we think it's going?
Yeah, where do you feel haptics is going for the future of gaming experiences?
I mean, it's obviously the missing piece of the puzzle, right? So graphics development tools and graphics for users have really jumped leaps and bounds every single iteration of consoles, or even now on the web. Same with audio. I mean, if you look at what's in PlayStation 5 with regard to audio, this is pretty incredible stuff. And for touch, this is just the missing piece of the puzzle. And hopefully, with the introduction of something that is more realistic in such a mainstream device like PlayStation, users might start to experience what haptics really can be. I think, unfortunately, we've been sort of dogged by older experiences, lack of design tools, lack of standards. There's a host of problems with why haptics really hasn't developed. One of them being a mainstream delivery system like PlayStation 5. What's missing for PlayStation 5, or maybe will be announced at some point, is a design tool. Like, how do you design haptics? This is a whole new field. How do you design what a footstep in snow feels like? This is not an easy problem. And a whole new, I think, design paradigm needs to emerge there. But hopefully with a platform that you can actually deliver exceptional experiences on, we will see this move. I mean, one, I think, fantastic example of haptics done extremely well is the iPhone. So the Haptic engine in the iPhone and the invocation of core haptics as an API to get fine-grained control over this exceptional motor means you can do things on millions of devices now that you couldn't do before. And so I guess what's sort of missing is for people to experience them and then for it to become mainstream. My assumption, and of course I'm biased because I work in a haptic startup, is that this will become mainstream and it will become something that people come to expect and people learn to do well. I suspect there will be poor implementations, a lot of them to begin with, but hopefully that best practices emerge, thought leadership helps people do the right thing, less is more, all of that. So I am very optimistic, but I am also very biased.
Great. And we have a question for Jules. Controversial question: is Soul being developed to possibly be an eventual replacement for JUCE? Will JUCE ever be replaced?
Never get rid of JUCE. That wasn't the idea with it. I think as long as people are writing audio code in C++, then JUCE is going to be around for that. I think ultimately, I mean, my kind of prediction for the world will be that as OSs get more and more security conscious, and as processing becomes more heterogeneous and moves on to different chips and gets more distributed, it's just going to be impossible to run your C++ code where you want to. In the same way, like, 10 years ago, browsers used to let you embed some C++ code in an ActiveX control or something, and gradually it just became JavaScript, and you could do everything in JavaScript, so that's fine. And I think in 10 years we're going to look back on plugins that were written in, and the idea of like having a door that loads other people's C++ code into the same names, into the same address space, and lets it just do whatever it wants. And the idea that OS would let that happen on its audio, if it has an audio chip over there, whether it's a DSP or a little CPU, I just don't think that entropy is pushing us away from that. I don't think that we're going to have native languages on these actually doing this job in the far future. In the near future, definitely there are, like, JUCE isn't going anywhere in kind of in the foreseeable future, because there's just so much code out there using it. There's so much C++ code. There's so much, so many companies with million-line code bases based on JUCE. So definitely not trying to replace it, but it felt to me like something would eventually replace it, and I didn't want someone else to make that thing. I thought, well, if something's going to displace this way of doing code in the future, and I think it will at some point, whether it's near or far, I at least wanted to have a hand in designing what that thing could possibly be, and having my go at it. But it's not. It's not a replacement. It's a parallel thing for the foreseeable future.
Okay, great. And my dog Toast has decided to join us for this live stream. She's learning the code. So another question for Ania. Do you use C, Python, or PyPy?
Yeah, so I mentioned briefly that I tried using PyPy. I use CPython mostly. I used PyPy for those who have never heard of it. CPython is the default Python interpreter written in C, whereas PyPy is a Python implementation written in restricted Python. It's supposed to be faster, and it is for many use cases, but not all of them. And I wrote like a silly, simple sampler and benchmarked it on different Python implementations. And PyPy was slower, actually. That was very disappointing, and I've been meaning to find out details why. I think maybe the PyPy implementation of NumPy, which, like, NumPy is a library offering a lot of vectorized data types. Maybe this is a problem. I've been meaning to look into it, but like the fastest was so far was the Python 2.7 implementation of CPython with all the computer processors switched off by one, right? So like Python can't run like on different processors. So it's basically gonna be like switching and locking, process. So basically when you disable all the cores but one, your Python code executes faster. So yeah, long story short, I've tried using PyPy and it didn't yield promising results. It would be nice to understand why and maybe help advance the project to improve this, but it's not the case yet.
Fantastic.
I think we need to wrap up soon, but actually I just saw on the Zoom chat that Ania, you have a question for Jules.
Yes. So I have a question about Sol. Since you mentioned that it's domain language, right? Like it's has the simplified syntax, and I wonder what it's like to debug in it. What it's like when everything works. I assume like it's great. It works out of the box most of the time, which is great. But what happens in the situation when actually something doesn't work? I don't know what the licensing plan for Sol is either. So is it possible to see the underlying code and be able to figure out what's going on, debug it? So I've just been wondering about.
So you're talking about debugging Sol itself and not a Sol program?
A Sol program,
yeah.
Guess, or maybe Sol itself. Yeah, it depends what.
There's all different layers of debugging here. We haven't written the Sol debugger yet. It's on the to-do list. That's a tough one. It'll probably end up being an interpreter, so you can step through, and we'll have a tool that can like interpret the code, so you can inspect things. One of the nice things about the language as well is that because the whole thing is kind completely state-based. Like the state of a Soul program is one chunk of memory, literally with one chunk of memory, everything stays in one place. You could actually have a debugger where you can scroll backwards and forwards in time. You could actually record the entire history of the state, or take snapshots of the state. So you can actually rewind to any sample that's been played at any point in the program, and actually then inspect every variable, which I think is kind of the ultimate, audio coder's debugging dream. Is like, oh, what was that click? Roll back a few seconds. Oh, it hit, and then look at the actual thing that happened. Then if you end up actually having a problem with the Soul compiler, JIT engine, generators themselves, yeah, we do ultimately want to make everything open source. That is definitely where we want to go. Right now, we've released most of it as open source, all the front end stuff. We're keeping back some JIT engine code, just because we kind of have some discussions going on, legal stuff and business stuff behind the scenes. So we're kind of holding some back, but ultimately I want to see everything out there and make it all completely debuggable down to the lowest level. That's the plan.
Great. So we have time for one more question, and that is for Ruth. What was the name of the boot camp that you had mentioned? And before I forget, afterwards, can you send me a link to all this stuff so I can put it in the video description?
Yeah, I've got all the links. Do you want me just to drop them into the Zoom chat now?
Yeah, that sounds great.
Okay, I'm going to do that. So the bootcamp is actually a local one. I live near Bristol in the UK, and about 5 years ago, when I left, I had a research and development job at a big telecommunications company here, and I left that, and I was immediately approached by the founders who were doing a localized course. It's a 3-month course to teach people how to code, because there was such a lack of resource within Bristol. Like, there was plenty of jobs and the skill wasn't there. So they approached me to start teaching, which I've been doing ever since. It's been an incredible experience. Definitely one of the most fulfilling things I've ever done. I really love teaching. The name of the company is Develop Me Training. You can just Google that, but they are Bristol based. So
okay, yeah. Develop Me
Training. Yeah, I could probably give you a link for that as well.
Great.